Decided to go ahead and start a series of videos explaining some of the intricacies of the codes, specifically ICC related codes. And I thought I'd kick this off with a maximum allowable quantity discussion as centered on Class 1B liquids and also Division 1.4 explosives from Table 5003.1.1 parenthesis 1 of the 2018 IFC. Now, why the 2018 IFC? Obviously, a lot of municipalities are going to use the 2021 or the 2024. I'm targeting 2018 because in the state of Idaho, that's what we're under, probably until January of 2027 when we're going to go to the 2024 edition. I want to touch just really briefly on a particular table within NFPA 30. This is the Flammable and Combustible Liquids Code. This happens to be the handbook. So here's the question for you. If you're dealing with maximum allowable quantities, MAQs, MAQs, so I'm going to refer to those as MAQs here on out. MAQs give you a specific amount of hazmat, hazardous materials, hazmat, within a area, control area. Control area is defined as a room or an area of a building that's it could be an entire building, but typically a control area is going to be separated by 1 hour fire barriers from other areas. And you can have up to, I think, 4 control areas per floor in a given fire area. I'm giving you those details because there's a lot of code requirements in terms of hazmat. Now, what I want to get into as well, there's a difference between the definition of hazmat from RCRA and from the IFC. RCRA was established in 1980 as the Resource Conservation Recovery Act, signed into law, I think 1980, maybe it was 81. But what that does is it defines hazmat, hazardous materials relating to the environment. And that's different from the hazmat associated with the IFC. So the IFC, particularly in Chapter 50, goes through and identifies a series of categories. And why I'm pointing out categories, those categories, they have specific quantity limits. So if you look at this table, this particular table in Chapter 50, it has a variety of defined hazmat categories from combustible dust, flammable solids, organic peroxides, water reactives. In fact, Chapter 50 in general has several tables associated with flammable gas, pyrophoric materials, etc. Tables that identify different types of hazmat. Now, I'm not going to go through and explain every category, but what I wanted to do is just target Class 1B liquids as well as the aforementioned Division 1.4 explosives. The reason for that is the things that come up the most. Like Windex, for instance. If you have alcohol within Windex, you're going to have a flash point. Well, are you going to treat Windex at the same level you're going to treat acetone? Intuitively, it makes no sense to do that. So I wanted to go through and explain some of the reasoning behind how we manage hazmat as defined in the IFC within control areas. Let's go ahead and take a look at the code really quick. So I'm going to use the 2018 version for the digital copy. I'm doing that because this is what Idaho uses. But if you look at this table, 5003.1.1 parenthesis 1, it's going to be the same whether it's 2021 or 2024 in terms of quantities. And if you scroll down to flammable liquid, you have the section here on flammable liquid. You have 3 different categories of flammable liquid. You have 1A and 1B and 1C. And let's go through and define what that is. Flammable liquid is a liquid having a closed cup flash point below 100 degrees Fahrenheit. And then you divide these 3 categories differently in more granularity. So let's look at Class 1B specifically. Liquids having a flash point below 73 degrees Fahrenheit, having a boiling point at or above 100 degrees Fahrenheit. So the delineation between flammable and combustible liquids is 100 degrees Fahrenheit. So basically room temperature. I do want to point out when you get into what's above 100 degrees Fahrenheit or above, it's called combustible liquids. They don't ignite as easy. I mean, for instance, try igniting some diesel with a match. It's kind of challenging. And that's because at room temperature, it doesn't produce enough vapors to ignite or to flash. The other thing I wanted to point out is what is flash and fire point. So if you look at flash point, let's go ahead and find this definition in the code. Now this is coming from chapter 2 of the International Fire Code. That's where the definitions are. But flash point is the minimum temperature in degrees Fahrenheit at which a liquid will give off sufficient vapors to form an ignitable mixture with air near the surface or in the container. So flash point is different from fire point. This is what I really want to bring up. Fire point is the lowest temperature at which a liquid will ignite and achieve sustained burning. So picture some liquid, a pan of some kind of flammable liquid like gasoline, for instance. There's enough vapor being produced from gasoline, I think intuitively we recognize if you bring a pilot ignition source to that gasoline, those vapors like a match, you're going to ignite and then the bowl of gasoline is going to continuously burn. There are other chemicals, let's say you have alcohol with some water. It will flash. You might be able to have enough vapor coming off of there in a closed cup, kind of capturing those vapors that you could introduce a match to that area and it will ignite, but it'll quickly extinguish. There's simply not enough evaporation. There's not enough mass flow rate of that flammable gas, that flammable vapor from that liquid to be able to sustain combustion. So that's the difference, flash point and fire point. But let's just really quickly look back at the table. So what you have here, let me explain how this works. For flammable liquids, so I'm specifying, let's look at 1B and 1C. You're not going to see 1As a lot. That's where you have a boiling point under 100 degrees Fahrenheit. Typically, it's not something you're going to see outside of a pressurized vessel. So I'm just going to concentrate on 1B specifically. 1B would be things like acetone, alcohol, gasoline. I mean, that's the types of a hazmat that would fall under class 1B flammable liquid. What this says is within a control area, once again demarcated by 1 hour fire barriers, you can have up to 120 gallons aggregate of a class 1B liquid. Okay? But take a look very carefully at these footnotes. Footnotes D and E right there. If you go down to the footnotes, let's start with D. Maximum allowable quantity shall be increased 100% in buildings equipped with a sprinkler system. I also want to point out this, 903.3.1.1. A lot of people get confused about that. This is specifically NFPA 13. This is not NFPA 13R or NFPA 13D. NFPA 13R and D allow greater latitude if you're doing like an apartment complex of a certain size or a residential building. You're allowed to use D or R on those type of structures. NFPA 13 is a lot more expensive, a lot more inspection, testing, and maintenance, and therefore it's kind of higher end. It would be your commercial applications. But you have to have an NFPA 13 compliant suppression system to go with this 100% increase. Now, what does this mean? Let's go back and take a look at flammable liquids, 1B. Normally, I'm allowed 120 gallons in control area, but if I have the NFPA 13 compliant suppression system, I'm allowed to go to 240 gallons. So I double it. Now take a look also at this additional footnote E right there, E. Let's come on down to E over here. Maximum allowable quantities shall be increased 100% were stored in approved storage cabinets. So flam cabinets. So if you're in a suppressed building, NFPA 13 compliant suppressed building, and you have flam cabinets, the normal limits for that hazmat, flammable liquid class 1B, you can go up to 480 gallons. So instead of 120, you can double it for suppression, and then you double it again for hazmat container. Okay, that's great. Now, what I've noticed looking through SDS's, safety data sheets, formerly MSDS's, material safety data sheets. They changed the name, I don't know, 10 years ago and made it a little bit more formatted. SDS is, that way, regardless of the chemical you're looking at, you always go to section 9 for physical properties, for instance. It's very formatted. MSDS's were kind of Wild West. There wasn't a lot of law there in terms of formats. So my observation, whether it's an MSDS or an SDS, let's take Windex. If you used an alcohol-based Windex, let's say 3% Windex, some MSDS or SDSs would show it as having a flash point. Now let me just show you something. I went ahead and quickly looked up a few MSDSs just so I can share this with you. It's kind of interesting. Various flash points for Windex. So I have greater than about 200 degrees Fahrenheit. That puts it into basically a class 3B liquid, combustible liquid. Come over here, it says a flash point below 200 degrees. Well, what does that tell me? Nothing. Not applicable. So this Windex doesn't have a flash point. But let's look at this. This is interesting. Let's take a look at this. What does it use? It uses, let's go to section 3 here. Okay, take a look at that. Buto-oxyethanol right there. It's a alcohol, 1 to 5% concentration. So you have an alcohol, what's called a miscible liquid, something that is easily dissolved into water. 1 to 5%. Technically speaking, I don't even know how to pronounce that, oxyethanol, it is a combustible liquid. So here's the question for you. If I have a miscible combustible liquid mixed with water, is this case for this variety of Windex, why does it show no flash point, period? None at all, no matter how much you heat it up. See, it doesn't intuitively make a lot of sense. Let's look at some other varieties. Flash point right there, another version of Windex, 130 degrees Fahrenheit. Here's another one, 185 degrees Fahrenheit. This is Windex as well. Another Windex, 185 degrees Fahrenheit. Another Windex, take a look at that, flash point 80 degrees Fahrenheit. That's actually class 1B liquid right there. So there's a lot of Windexes out there, and they have different SDSs. And get this, I've noticed, in fact, exactly the same Windex varieties from different years, but it would be the same chemical markup. And it has SDSs that show different flash points. And I think a lot of times it comes down to these percent by weight. Take a look at those variations. So in this particular one, iso alcohol, 10 to 30%. They're not going to tell you exactly how much. They're going to give you this range. And I think there's some proprietary issues, corporate protection. But the point is, it's obvious. In this case, this is interesting. Take a look at the percent range here for iso. 10 to 30%. Now this comes up. I want to show you something really interesting. Let me jump over to another source of NFP 30. So if I go to the 2018 version of NFP 30, this is in chapter 16 of NFP 30. And what it does, it talks about miscible liquids. Now I'm going to be very clear in the definition of a miscible liquid. A miscible liquid is a liquid like alcohol. You can pour it into water and it evenly kind of, dissolves in the water. Whereas if you had gasoline or some fossil fuel based solvent, you add it to water, it's going to have a demarcated layer. So let's target specifically miscible liquids, because Windex is an example of a miscible liquid. Well, according to this table, this decision tree, if you have a miscible liquid where the concentration is less than or equal to 20%, you're going to protect it by a class 1 commodity in NFP 13. Now, what does that mean? A class 1 commodity would be like steel, or it would be concrete. In other words, NFPA does not see this as having any fire-related threat above steel, because that's how you're protecting it, like a class 1 commodity. So the question is, how does that relate to fire point? Well, I sat down with a couple members of the NFP 30 committee one year when I was at an NFPA conference, and we chatted about this. And the point is, if you're below 20% or 20% below, you really don't have a fire point for miscible liquids. Consequently, you don't have to apply onerous rules from Chapter 57 of the IFC. Well, how does Chapter 50 apply? Let's look really quick at Chapter 57. I want to show you something kind of interesting here. If I jump into Chapter 57 for flammable and combustible liquids, this is Chapter 57, and I go down to the non-applicability section, what do I have to apply as far as rules in Chapter 57 to a liquid that doesn't have a fire point. It has a flash point, but no fire point. What do? This section, storage and use of liquids that do not have a fire point when tested in accordance with ASTM D92. Okay, now this is the thing that gets me. If I have a control area full of Windex, the Windex does not have a fire point. I have less than 20% miscible liquid. Let's say I have, in the example before, the MSDSs that we previously looked at. We looked at some MSDSs that have, a wide range in terms of the product. So you have, like that example I just showed you, it was 10 to 30% of ISO. I'm not going to go back and find that at this point, but what I'm getting at is if you have a chemical with less than 20% miscible liquid and it doesn't have a fire point, then do the onerous requirements of Chapter 50 in terms of storage, do they apply? Are you limited? The flammable liquid definition does not have an allowance for fire point. It's strictly based on flash point. But why am I treating a Windex with 5% alcohol or 10% alcohol the same as I would with pure acetone or even gasoline? And this is a confusing point to me. And I've had this conversation with a couple members, like I said, of the NFPA 30 committee, and they said basically the MAQs don't apply. Maximum allowable quantities, MAQs, MAQs, they don't apply if you don't have a fire point. I'm not going to see that anywhere in the code though, period. You don't see that. I talked to the state fire marshal as well a couple times on this. And he likewise didn't feel that the MAQs applied to things like Windex. Now, other people I've talked to, some FPEs, they've said it does. So there's a lot of nuance, and that's where you have to have some HJ discretion in terms of are you really worried about it flashing and causing issues, especially in an open storage room where you can't concentrate those vapors. So what I've done and made the call is I don't worry about Class 1B liquids, for instance, that don't have a fire point. Technically, when I had that discussion with the NFP 30 code committee members, they said maybe 15% would be more appropriate in terms of guaranteed not to have a fire point. And yeah, I guess it's your call. But for me, I don't worry about Windex. The 480 gallons, if you're in a sprinklered facility in hazmat containers, if I go above 480 gallons, I'm going to argue I'm not out of compliance. I don't worry about it. There's some HJ discretion there. So similarly, I applied the same thing to Division 1.4 explosives. So take a look right here, Division 1.4. Those are small arms ammunition. Those are bullets. And what this says is I'm allowed 50 pounds of ammunition in all explosive storing facilities have to be suppressed. But if I am in a hazmat container, I can double that to 100 pounds, okay? I'm not allowed the addition for sprinklers to double that because, look, you can't store explosives outside of a sprinkler facility based on the code. So the question is, does this apply to the brass and lead and bullets? And furthermore, are there ways to avoid this limit, this 50-pound limit or 100-pound limit if you have like some kind of a container? Let's just take a look really quick at Chapter 56. Chapter 56 of the IFC, that is for explosives and fireworks. If I come down here to Item 3, so exception Item 3, the possession, storage, and use of small arms ammunition where packaged in accordance with DOTn packaging. So have you wondered how can Walmart and gun stores, Dick's, whatever, how can they have literally thousands of pounds of ammunition in their mercantile environment? Because I guarantee they are not an H3. And what I mean by H3, let's take a look at the code again. If you cannot meet these limits for Division 1.4, 50 pounds or 100 pounds if you double it, then you have to be in a high hazard Group 3 occupancy. Well, I guarantee that those mercantile occupancies, Walmart for instance, it's not an H3. Yet they clearly violate this 50-pound limit for their bullets. Now the question is, how do they do that? And if you think about it, coming back over here, all of their ammunition is stored in packaging. And if you look at the packaging, the way the DOTn limit is, okay, hold on a sec. The way the DOTn packaging is, you're limited to 66 pounds. I believe that's the threshold limit. So whether you're in those nice cardboard containers with the individual plastic inserts or in an ammo can, it would meet the definition of DOTn packaging. So consequently, if you look at this, Chapter 56 does not apply if you are packaged and maintain packaging in those containers. Well, I had to make a call on this. How does it apply to your hazmat, Chapter 50, the table 5003.1.1 parenthesis 1? How do those quantities apply to that table? Does this exemption allow you to bypass the limits in that Chapter 50 table? I had this discussion with the state fire marshal, and his interpretation is like mine. Now, granted, maybe you have some funky situations where you're warehousing incredible amounts. You might want to reevaluate it and look at it closely. But for me, if I'm maintaining DOTn packaging, then I am going to be willing to violate that 50-pound or the 100-pound limit. And that's what it comes down to. So we had a discussion, the state fire marshal and I, just trying to clarify this, that we don't believe Chapter 50 applies to small arms ammunition if you maintain your DOTn packaging. Now, some people are going to differ with that. And if you are one of those individuals, please let me know. Go ahead and put in the comments. I'm just throwing out some stuff that I've learned, that I've incorporated in my profession. Maybe I'm totally off. I'm looking for some direction. But I do not worry about miscible liquids under 15%. Technically, that decision tree allows you to go by 20%, but definitely not under 50% alcohol content within a liquid. I'm not worried about flashing in an open storage environment, and consequently, I don't worry about the MAQs for things like Windex. I would for other stuff, definitely enforce it 100% if I'm above that 20% threshold, no question about it. But I'm not worried about hitting the maximum allowable quantities, driving a high hazard occupancy for miscible liquid. Likewise, I'm not worried about driving a high hazard occupancy for small arms ammunition if I maintain DOT packaging. Hey, thank you for your time. Hope you got something out of this. If you see things differently, throw it my way. I'd like to know your opinion. But I think I'm reasonably justified in the stance I've taken to manage the various facilities I either consult for or directly oversee. Thanks for your time and have a good day.